including energy, weight, blood sugar, and longevity and aging. It boils down to only one thing that's happening inside your cell, which you can't obviously see. About a month ago, during one of my Saturday health sessions that I do with a few people in my apartment complex, a woman in her 50s, she said, I've not been having good sleep for a very long time. It's been for months. And she apparently wakes up around 2:33 every night and then stays awake till 5:30. We made one small change. We tried a lot of stuff over a week, and then we figured that she was doing pretty much most of it right, but we made one small tweak to her schedule, and her sleep slowly transformed. I would say it improved. So today I want to talk about something that plays the fundamental role or reason behind all of this, including energy, weight, blood sugar, and longevity and aging. It boils down to only one thing that's happening inside your cell, which you can't obviously see. It turns out that she didn't actually have a sleep issue or a disorder. She had a power supply problem. Do you know what we are talking about? Yeah. So today we're going to talk about the power plants inside your cell that ran out of fuel in her case and sounded out the alarm. We'll talk about, yes, mitochondria, a deep dive into the power plants of the cell. So what I'll cover roughly is about the mitochondrial basics, something that people should know, and why it matters, what damages them, how it shows up in your daily life, what improves it so that you can improve your energy production, and how to measure in terms of indications, obviously. So, when I look at the basics, why it matters, what damages it, how to improve it, and how to measure the progress. Cool. So, let's start with section number one. What are mitochondria? So, we'll establish some of the basics. So imagine a city or your own house. If your house is your cell, you have, let's say, electricity coming in or some power generation equipment within that, that's your mitochondria. So for a city to function or for your house to function or for your body to function, we have trillions and trillions of cells, and each of those cells has mitochondria. There are some exceptions that we will talk about, but imagine mitochondria or organelles. That is, an organ within a cell is called as an organelle. So imagine the body like a city, and mitochondria are its power plants. So that is, they produce enough power so that your cell can function and then your body can function, or your entire organ can function. Everybody needs this power. Now, how do they function? So they take two inputs. One is food, the nutrients that you eat, and oxygen that you breathe in. They convert these two ingredients into something called as ATP, adenosine triphosphate. It's enough if you remember that it produces energy. That's more than important. So this is the actual fuel that your body runs on. The fact that I'm talking, the fact that you're hearing me or watching me, it all boils down to something functioning in you, which means it is all consuming ATPs, right, in some form. So these are mitochondrial outputs. So mitochondrion is one single unit. It is filled with about 17,000 biochemical assembly lines. Think of it as a large factory with multiple assembly lines. Mitochondria is filled with 17,000 biochemical assembly lines, all designed to produce a molecule called ATP. That's all you need to remember. The body's major, most elemental fuel. Another factor that you have to understand is they just not produce energy, they also control the flow of energy. Now, organs like brain, heart, muscles, and liver, some of the major organs that we are usually concerned about, contain larger number of mitochondria per cell. Okay, so we'll go a little deep into that now. Heart muscles, they are the ones that have the maximum number of mitochondria per cell, about roughly 5,000, because it's quite obvious, right? Heart keeps pumping, it doesn't stop, it can't sleep. So you need more mitochondria so that you can produce more energy, as simple as that, or let's say more ATP. Liver cells, roughly about 1,000 to 2,000, because there is a heavy metabolic workload. When you need to give it rest when you don't eat, otherwise it's functioning all the time. Skeletal muscles, about 1,000 to 2,000, can increase significantly with training, right? We'll cover that as well. Brain, yeah, I know you were waiting for that. Around 2,000. Brain consumes 20% of your total energy. So obviously it's all the neurons at the end of the neurons and the synaptic connections, they have everything padded together. Fat cells, very few, minimal energy demand, lazy parts, right? Lazy cells. Now, the exception that I spoke about a few minutes ago, red blood cells, zero. Red blood cells don't have mitochondria, the only cells with no mitochondria. Now, I'll also talk about how these mitochondria look across different parts of the body, just for you to know. It's deeper into biology, but I think it's good knowledge to understand. In muscle cells, they're densely packed in rows along the muscle fibers, structured for sustained, repeated energy output. In heart cells, they occupy 40% of the total cell volume, right? This is the maximum capacity utilization. As in, if you in your house, let's say if you have 4 rooms, almost two out of close to 2 out of 5 rooms are kind of occupied by mitochondria. The heart is essentially built around them. Liver cells, they are larger and more varied in shape because liver does so many different metabolic jobs. Brain cells, they cluster near the synapses, right where the energy demand spikes during thought and communication. Beautiful, isn't it? Now, some trivia for you. In egg cells, they contain up to 100,000 mitochondria. You can guess why, right? The highest of any cell. Nature ensures reproduction gets maximum energy priority. That's why. Okay, cool. So now that we understood what is mitochondria, how is it structured, and different organs, how many mitochondria are packed in every cell, we now step into section number 2. Why it matters, right? Why do we need to improve mitochondrial health? It is quite apparent by now, but we will still go deeper into it. Imagine a house without electricity. What will happen? So imagine a body without energy. Can you do anything? Can you get up? Can you move your muscle? Can you talk? Can you see? No, you can't, right? So let's look at it. Number 1, better energy. This is quite obvious because your mitochondria is producing a lot of energy. Fat burning. Mitochondria are where fat is actually burned. More mitochondria means more fat oxidation capacity. Very interesting. Note this point. Third one, blood sugar control. More mitochondria means muscles absorb glucose more efficiently, directly reducing insulin resistance. So it has a lot of correlation with things like diabetes. Longevity. Mitochondrial decline is one of the most consistent markers of aging. Improving them essentially is slow biological aging. So obviously, people want to remain young and have a good quality of life and also have a long life. That's very important. Brain health. Cognitive decline, Alzheimer's, depression all have mitochondrial dysfunction as an underlying component. Immune function. Immune cells are highly mitochondria dependent. So obviously we have given you enough reasons, right, from brain to heart to diabetes to blood sugar control, longevity, looking good, skin health. So mitochondrial health is foundational for almost everything that you do, see, or basically every facet of your life. Let's now look at what are the basic things that we do that most likely damages the mitochondria or damages the cell. Now, a few of them. Now, whatever I'm talking about or I've spoken about is not, it's like not encyclopedic where I've covered every aspect of it, but I'm just taking a few aspects of it that I think is important for this small podcast. So it's not like it encompasses everything that you can potentially think of. Just a caveat. Section 3, what damages them? Chronic stress. Cortisol is directly mitotoxic at high sustained levels. Number 2, ultra processed food, particularly seed oils and excess fructose, that is sugar. Alcohol impairs mitochondrial membrane function. Number 4, sedentary lifestyle. Mitochondria shrink and reduce in number without demand. When there is no energy demand from your body, let's say you're lying all the time, your energy consumption or energy requirement is low, which means the body is not going to produce and then it's going to shut down some of those power plants. Number 5, environmental toxins. Pesticides, heavy metals directly damage mitochondrial membranes. Things like pollution, etc. and other environmental factors will cause mitochondrial damage too. So you have to remember that. Essentially, think about sedentary lifestyle and food as a main reason, and of course, lack of sleep, the most important, because we'll go deep into that. Don't worry. But at a high level, I want you to remember stress, lack of sleep, ultra processed food intake, a lot of sugary items, alcohol if you consume a lot, of course smoking, everything will affect it, and sedentary lifestyle. These are the basics. So essentially you can look at mitochondrial dysfunction in some form as a lifestyle issue. You also have to remember that with the age your mitochondrial function will reduce, in the sense that this normal decline is expected, but if there is a rapid decline, that's what accelerates your aging and mitochondrial dysfunction to the point that we face a lot of issues that I just spoke about a couple of minutes ago. Now, one thing you have to remember about sugar and alcohol, these just don't add empty calories. Okay, you don't have to worry too much about it. They actively interfere with the machinery that produces energy and the machinery that repairs the same machinery. So, essentially, if you're taking too much sugar and alcohol, I'll not go deep into that, all that AMPK pathways and other things, but or mTOR pathways. But remember that sugar and alcohol are extremely bad for mitochondrial health, as is other ultra processed foods. So we spoke about what damages them and how does it show up in daily life. Like that's a question that you might have. And we're still in section 3, right? Constant fatigue. Obviously, I don't have energy to power the house. The lights are off. The washing machine is not running. The fridge is also off. So there is constant fatigue and you cannot really move well. You will feel tired most of the day. Poor focus and brain fog. It's very simple. If the brain doesn't get enough supply of glucose and energy, the same reason you can't focus and you will have a brain fog. How do you feel the day when you had alcohol the next morning? Are you able to focus in an office meeting? No, right? Yeah. Low stamina and slow recovery, pretty obvious. Belly fat and insulin resistance. This kind of ties very closely to what we discussed about blood glucose regulation a while ago, or let's say insulin sensitivity. Poor sleep and inflammation. This is quite obvious. So it's a cycle. Poor sleep leads to mitochondrial dysfunction, and then mitochondrial dysfunction, it shows up in poor sleep and a lot of inflammation. Your skin, eyes, face, hair, everything will start show signs of wear and tear, and let's say encompasses something like an accelerated aging. So suddenly you see someone looking young for his age or her age versus someone who looks too old for his or her age. Sorry, all of this is accelerated aging, and that's heavily reliant on how well your his or her mitochondria is functioning. So now we have covered the basics. Now let's go into how do we solve this problem. Let's say you've already been affected or you have some of these symptoms that I spoke about, and assuming that you want to fix it in case you want to live long, you want to have a good quality of life, etc., and then you want to look youthful, energetic, and have better focus and good career and good life, whatever your wishes, then the next section is for you. We'll go a little deeper into that, and I'll go into some tangential areas as well, which are important for you to understand. Now, how to increase the number and quality, right? So there are two aspects of it. One is we discussed about the number of mitochondria per cell depending on the region of the body as well, muscle, heart, liver, etc. So we are looking at two aspects. One is how do I maximize the output from one mitochondria and also have more mitochondria. So the more will help you generate more power, and each of them, when they function fine, each mitochondria produce maximum output, then you have good number of output per cell, which is what you want. Now, more mitochondria equates to more energy production capacity, equates to better performance, faster recovery, better glucose burning, fat oxidation, sharper cognition, thinking, energy, etc. Imagine upgrading your car from, let's say, a twin cylinder to a 4-cylinder or 4-cylinder to 8 cylinders, better output, amazing pickup. Okay, cool. So the interesting part about all of this, so maybe we discussed a lot of negatives so far of life, so I know you want something more optimistic. Let's get into that. Mitochondria is trainable, right? Just like a muscle. Exercise, particularly zone 2 cardio, directly stimulates mitochondrial growth. Essentially, you need to create a demand for your cells to produce more mitochondria. They multiply with demand. The process is called mitochondrial biogenesis. So if I have a demand, if I move a lot, if I need more energy, then the cell realizes, oh, I need to produce more mitochondria. Of course, it needs a lot of different types of signaling and pathways and nutrients to build mitochondria, but at least you need to start triggering your body that you need to produce more mitochondria because I need more energy, right? So that's called mitochondrial biogenesis. You literally grow more when you stress the body correctly. So not the negative stress that we spoke about, like things like alcohol or smoking, etc., but more like positive energy like exercising. Sleep is when they repair, which loops back perfectly to the sleep improvement that I spoke about for one of the girls that we spoke about, the 50-year-old lady who had poor sleep. Her sleep improved. So obviously sleep is the time when mitochondrial repair and genesis happens. So ensure that you get a good sleep. In almost all my podcast, I keep saying sleep is your superpower. It's a miracle. Don't ignore it. Not for anyone, not for any company, not for anybody. Protein feeds them. Mitochondria need amino acids to function and repair themselves and to build. So essentially, I think if I have to summarize this, it's just 3 points. You need a trigger to produce more mitochondria. The trigger is energy requirement, which comes through exercise of some form. Now that there is a trigger, you need some foundational blocks or nutrients to build it. That becomes your food intake, or let's say good nutrients, micronutrients, and proteins, etc. Not just proteins, nutrients, micronutrients, and proteins. All of them are required for mitochondria to function, also to build them and also to repair them. So you need to build, you need to repair the damaged mitochondria, and you need to kill the damaged mitochondria and produce new ones depending on the nature. So that's why we need good nutrients. Otherwise, you can't build it. When do we do it? Sleep. Sleep is the time that they repair, produce new mitochondria, etc., etc. So obviously, these three go hand in hand. The foundational aspects: exercise, sleep, good nutrition. Now, let's look at some of the exercises and exercise forms, and also talk about potentially what organ or specific organs it can potentially help more with. Not that it doesn't help other parts, because you can potentially increase mitochondria in a localized way. So it is not systemic. You can increase mitochondria locally. I don't know what the biological term for it is. I think it is like opposite of being systemic, right? Let's look at zone 2 cardio. I think this is been shown to improve mitochondrial requirement and activity. Sustained moderate intensity exercise, 30 to 45 minutes. Most powerful trigger for mitochondrial biogenesis. This is what we spoke about. This is the single biggest lever. Number 2, strength training creates demand that forces mitochondrial adaptation in muscle tissue. We'll go to different organs in a little while. Cold exposure. Cold showers, cold water activates brown fat, which is extremely mitochondria dense. Intermittent fasting for your liver. Metabolic stress from fasting triggers mitochondrial cleanup. It's called mitophagy, just like autophagy. Quality sleep, number 5. Repair and regeneration happens almost exclusively during deep sleep. Sunlight. Morning sunlight directly stimulates mitochondrial activity, particularly in skin and eye cells. Protein intake. Mitochondria need amino acids for structural repair. We just discussed it along with other micronutrients. Now, one of the challenges that I've generally seen is, there's so much to do. How do I do it? So you don't have to worry too much. Just pick 1 or 2 start for the week, and then things will improve. But essentially, zone 2 will give you a lot of impetus to increase the mitochondrial number. The duration matters. Needs to be sustained for 30 to 45 minutes minimum. Short bursts don't trigger the same response. So you have to remember that any of these things that I speak about needs sustained amount of effort consistently over months. So don't think that you'll go under the sun and suddenly you'll improve your mitochondrial health, or you'll do zone 2 cardio once in a week and expect to see tremendous gains. That is unlikely to happen. It is beneficial, but for you to have sustained benefit, you have to do it consistently, at least 2 to 3 times a week. Now, HIIT, just like zone 2 cardio, is known for mitophagy and quality of mitochondrial health, or let's say the output. So we spoke increasing the number of mitochondria, and you also want to improve the quality of output that it produces, that is the amount of energy that a single mitochondrion can produce. So that apparently HIIT seems to play a great role in it. Why it does is create significant cellular stress rapidly. This stress triggers mitophagy. Damaged mitochondria get flagged and removed. It also triggers autophagy, forces rapid ATP demand that existing mitochondria can't fully meet, signaling urgent adaptation. So basically, the trigger for adaptation is much faster in HIIT compared to zone 2 cardio. So why you need both? Zone 2 builds the quantity, high intensity cleans out the damaged ones and improves quality. That is all you need to remember. Together they create a complete mitochondrial upgrade cycle. So in a way, if you think of it as a factory, like the analogy that we took some time back, zone 2 building more production units, like more power plants are getting produced for the city. HIIT quality control and removing the faulty machines, the power plants that are not functioning, remove them. All right, that's what it is doing. Strength resistance training increases mitochondrial density, specifically in muscle tissue. Muscle is the largest glucose sink in the body. More mitochondria in the muscle equal to dramatically better blood sugar control. directly relevant for any person who has insulin resistance, right? So for you, building muscles will help you a lot. Great. One final takeaway from all of these, some of these exercises that I mentioned, whether you start with HIIT or cardio or a mix of it, or strength training, swimming, cycling, whatever it is, consistency over months is what drives mitochondrial density. You have to remember that. Now, putting it together, I'll just summarize the different parts of the body and what the primary exercise means to that is going to be. For heart, zone 2 cardio 3-4 times a week is the recommendation. For liver, intermittent fasting and reduced sugar intake. Beautiful. Of course, take good nutrients as well. Brain mitochondria, coordinated aerobic activity, learning, and good sleep. These are the three main drivers for brain mitochondria. It could be a learning new language, learning a new musical instrument, whatever it is going to be. Number 4, muscle. For muscle, it's strength training plus zone 2 cardio. I'll repeat it so that you can remember. Heart, zone 2 cardio of any form. Liver mitochondria is fasting and reduced sugar intake and eating a lot of whole foods. Brain, learning, aerobic activity, and sleep. So for brain, apparently sports activities is much better. So they say coordinated aerobic activity, not just aerobic activity. So they call it coordinated. So anything like a sports, it could be any sport that you pick up, apparently is better for the brain mitochondria, along with learning and deep sleep. Muscle, strength training is quite obvious, plus zone 2. So that pretty much takes care of the major organs of your body. Apart from all of this, one of the things that's been known to help all of these organs plus in general is sauna. And in fact, you can try it for 2 to 3 times a week if you can, but it is extremely good for your mitochondrial health. I'll also give a little bit of reasons around that. I won't go deep into it because sauna itself is a separate topic that we can do as a podcast. The specific mechanism is through heat shock proteins, HSPs, molecular chaperones that are released under heat stress. What do? They repair damaged mitochondrial proteins, protect mitochondrial membranes from oxidative damage. So we'll talk about free radicals and ROS, etc. at a high level, but essentially it's to prevent you from oxidative damage. Help refold and restore partially damaged mitochondria rather than destroying them. Now, sauna essentially you can think of it as a mitochondrial repair and production stimulus more than a growth stimulus. Body is an efficient machine. If a mitochondria is damaged, the first thing it's going to try is I'm going to repair it to get it back to great production capacity, so that your washing machine can start functioning or your fridge can start cooling. So that's what it's going to do. So sauna will help you do all of that, or some of these activities will also help you. It's enough that if you, it's very similar to any aerobic activity, but if you find it a little, say, difficult to run or let's say swim, go sit in the sauna. It has reasonably good adaptations for mitochondrial health, not for growth, but for maintenance and repair. Cool. So it helps with heart, it helps in BDNF, etc. I won't go deep into it. So it seems to help all the mitochondria and all parts of the main organs that we spoke about. One important tip that I found along with sauna is to kind of alternate that with cold exposure after sauna. So they say that extreme heat and also extreme cold of some form is very beneficial for mitochondria. But if you're in a situation where you can't get ice baths done or it's very difficult in your city, just alternate your sauna with a normal cold water bath in your shower. They stay for like 4 minutes, 5 minutes, and keep alternating a little bit. That seems to help quite a lot. Sauna triggers heat shock proteins and mitochondrial repair. Cold immediately triggers a separate set of cold shock proteins. So just like HSP's heat shock proteins, you have cold shock proteins. The contrast activates mitochondrial biogenesis more powerfully than either alone. Also dramatically increases norepinephrine up to 300%, which is a direct mitochondrial activator. So this is enough. So practical suggestion, if you are not able to get a very cold plunge, just enter sauna session with a cold shower for 3-4 minutes. You get a portion or let's say less part of that benefit. Still, that's good enough. Cool. So we discussed about some of the exercises that will help you with mitochondrial quantity and quality. What about food, right? So essentially, how is the energy production is just two forms, right? You need source of food and then you need oxygen which you breathe, which anyway you do, so that's not a problem. So let's also talk about some of the food or let's say nutrients that are very important for you to improve your mitochondrial biogenesis. So I'll read some of these nutrients. COQ10, essential electron carrier in ATP production chain, declines significantly with age. Magnesium, required for over 300 mitochondrial enzyme reactions, majority of people are deficient. B vitamins, B1, B2, B3, B5, direct cofactors in the Krebs cycle inside mitochondria. Iron, required for electron transport chain function. Zinc, mitochondrial enzyme function and antioxidant defense. Alpha lipolic acid, AL, powerful mitochondrial antioxidant, also a Krebs cycle cofactor. L-carnitine, L-carnitine, transports fatty acids into mitochondria for burning. Without it, fat can't enter. Cool. Now, I'll also go through some of the mitochondria supporting foods. So these are some complex terms that I read. Some of you obviously will know magnesium, B vitamins, iron, zinc, etc. How do you get the 10, right? It's either through some direct food that you eat or through some supplements. I'll not talk about supplements. You can Google it, but I'll at least talk about some of the foods for both vegetarians and meat eaters that will help you improve most of the fundamental nutrients that I just read through. For the electron transport chain, that is your COQ10 and B vitamins, what is recommended? Organ meats, liver, heart. So it's quite natural, right? So liver, heart, etc. already had a lot of mitochondrial density. So obviously, it is the richest natural COQ10 source. Fatty fish, salmon, sardines, mackerel, eggs, right? So this is for vegetarians. Good news for you. And for vegetarians, whole grains, lentils, nuts, B vitamins. Second aspect, for mitochondrial membrane protection, omega 3s and polyphenols. Fatty fish, walnuts, flax seeds, chia seeds, berries, blueberries, pomegranate, strong polyphenol antioxidant content. So, any fruit, vegetable that contains a lot of antioxidants, just grab it. Because one thing that I forgot to mention is when mitochondria produces energy, it also produces some free radicals or oxidative stress, which are not good for your body if it produces a lot. A damaged mitochondria will obviously produce a lot of ROS and free radicals, versus a good mitochondria will produce more of energy and less of free radicals. So for your body to kind of do away with all of these free radicals and get them out of the system, you need to have good nutrients, which things like berries and your dark leafy greens and all this food will help you get this antioxidants kind of to neutralize these agents that are getting produced. So imagine a car, it's producing a lot of smoke, right? The engine is running at a high capacity and it is producing, or let's say engine is not running well also. You produce a lot of smoke, more than what is essential. That's your, think of them as your free radicals or oxidative stress in your body. Easier to understand. Okay, so fatty fish, walnuts, berries, dark leafy greens, spinach, methi, palak, turmeric specifically supports mitochondrial function, reduces oxidative stress. Green tea. So these are some good omega 3 polyphenols that you need to have. And for magnesium, pumpkin seeds, almonds, cashews, dark chocolate, spinach, leafy greens again, bananas. For fat burning machinery, your L-carnitine and healthy fats, grass fed meat, fish. It's slightly harder for vegetarians, is what it says. Avocado, olive oil, ghee, coconut. For NAD plus precursors, mushrooms, especially shiitake, peanuts, edamame, and dairy products. And for vegetarians, to fill some of the gaps that we just discussed, tofu, tempeh, paneer, protein with some B vitamins. Fortified foods or supplements for B12, vegetarians are very deficient in it. Pumpkin seeds, cashews for zinc and magnesium. Sesame seeds, spinach for iron. Right, cool. So I think we have kind of discussed the exercise forms that are required for mitochondrial health. We also discussed the food sources for good mitochondrial health and what specific nutrients are beneficial for it. Right? It's quite obvious. Colorful vegetables contain a lot of antioxidants. Look for any vegetable and fruits that contain antioxidant. A good quality protein source plus healthy fat plus nuts and seeds for minerals. Basically, the opposite of a beige, processed, carb heavy plate is what you need to eat for good mitochondrial health. If your plate has at least 3 different colors and a protein source, you're already feeding your mitochondria what they need. It's mostly about avoiding what damages them rather than finding exotic superfood. So avoid all your unnecessary processed foods or ultra processed foods that you eat, reduce their consumption, reduce sugary foods, and let's say eating outside as much. That's very important. And if you want to increase, let's say, mitochondrial biogenesis and its quality, eat some of the food that I've mentioned. These are whole foods that are available. Now, we've done all of it. Now, in what way can anybody measure their improvement in life? Like, how do I measure if there is an ATP output? So if there's a power plant, it produces certain amount of horsepower, for example, or megawatts, for example. So there is a way to measure it. In body, it's slightly tricky, but there are some proxies that you can measure at home or through some of the smart watches that you wear, not this one, that will help you understand if your mitochondria is functioning reasonably well or not. One of the gold standard, of course, is simple. If you guessed it, that's pretty smart. It's VO2 max, the gold standard measurement of how efficiently your body uses oxygen to produce ATP. Directly reflects mitochondrial capacity, can be tested in sports labs, or you go to any hospital as part of your TMT also you can test, or if your watch smartwatch can also capture it. Another way to test it is lactate threshold testing. This, a lot of people in the gym would be used to it, or people who are exercising a lot will understand this. This measures the point where mitochondria can no longer keep up with the energy demand. Now, let's say you have 4 power plants and you have to power 2 cities, and that is not enough, right? The power plant can't keep up and then says, oh, you know what, build more power plants, right? I can't really supply the power. So the body switches to anaerobic metabolism, so higher threshold. So if it can sustain higher demand, it basically means you have better mitochondrial capacity. So these are two proxies. Other proxies that I thought you should know is, easy ones to understand is resting heart rate. So higher the VO2 max generally correlates with lower resting heart rate too. So if your RHR, resting heart rate, is low, it typically means a good cardiac efficiency and good mitochondrial health. Recovery heart rate, again, another factor that most of the runners and other people who use smartwatches would be aware of. How fast the heart rate drops after exercise. Faster recovery means better mitochondrial fitness or quality. Number 3, energy levels through the day. If you don't have dramatic energy crashes through the day, you're reasonably fine at about 2 o'clock to 3 o'clock or even 4 o'clock till about you go to sleep. You seem to be having a better mitochondrial function. Again, don't get overtly worried that at 2 o'clock, 3 o'clock, you're slightly low in energy. That is kind of expected for every human. There are multiple reasons for it due to circadian rhythm and the fact that you've had a different type of lunch. But when I say energy levels through the day constant, more or less constant, right? A little bit of dip is expected, and that is how the body functions. Number 4, exercise endurance. How long after exercise your fatigue sets in at a given intensity? Let's say you're just a couple of reps and you're feeling too tired, you're not in a good shape, but if your endurance is pretty good, you can keep going for a good amount of time with good intensity. It just means you have good mitochondrial function. I think that pretty much covers all the main topics that I said or I promised that I would at the start of the session. What I will also do is do more of, let's say, some interesting aspects about mitochondria that I read or, let's say, chatted with the AI tool to understand more for satisfying my own curiosity. Some of it might be useful for you. For all others, since you've heard a lot, if you want to go away, bye bye, improve your mitochondrial health, put your shoes on and run or lift some weights. Cool. So for others who are continuing to stay, I'm going to speak a little bit more about some of the questions that people might have had after hearing me. You might be thinking, why add more mitochondria? Why can't we just produce more energy per mitochondria? Apparently, it depends on the surface area of the fold. So I'm not a biologist or I'm not going into DNA and other deep cell aspects, but I'll tell you at a high level. So basically, they say that when a mitochondrion can only produce so much of energy, and that is kind of pre-decided, as in the way it is folded. You would have seen that in the diagram, right? The more the fold or the better the fold, it is better. But the surface area kind of dictates how much of energy it can produce based on the input that it receives. So ATP production happens on the inner mitochondrial membrane through protein complexes called electron transport chain, ETC. The surface area of that membrane is physically fixed per mitochondrion. You cannot infinitely increase output from one unit. It is like asking one power plant to supply electricity for the entire country instead of the city. Okay, so I thought you should understand this. I also want to explain a little bit about fission and fusion. So It's an extremely complicated mechanism that I understood. So apparently, within the cell, when you have multiple mitochondria, the ones that are damaged, not producing enough output, sometimes is killed through a process called mitophagy. Sometimes parts of it is reused to build new mitochondrion. In sometimes it is merged with a well-functioning power plant or a adjacent mitochondria. In some parts it is divided into two if it is doing too well. In some parts it is merged with another one. Sometimes it is killed depending on the decision tree that the body has very clearly programmed depending on multiple conditions. I also spoke about something called as ROS and also free radicals. So I just thought I'll touch upon that. Heat and free radical problem. At maximum output, mitochondria generate significant heat and free radicals as byproducts. So this is a normal byproducts. Nothing to worry that a free radical is getting produced. So just like a car that runs produces smoke as part of oxidation of the fuel, similarly your mitochondria also produces significant heat and free radicals as byproducts. So the mitochondria, let's say its capacity is 100. Apparently, it operates all of these generators or power plants at about 60-70% of its capacity all the time and not at maximum capacity. And I'll tell you the reason why. This is fascinating, right? Very fascinating. Running fewer mitochondria at max capacity would create dangerous oxidative stress concentrated in a few units. More mitochondria distributes the load. Something software people will remember as load sharing or multiple DBs, for example. Each runs at moderate output, generating less damaging byproducts per unit. Think of it as running 10 generators as 60% versus generate 3 generators as 100%, right? So the distributed system is safer and more sustainable. Multiple systems to take the load, or if one goes down, another one takes over so that nothing gets shut. Brilliant body adaptations. Mitochondria damage and die regularly. So that is happening as we speak. Trillions of cells are dying every day, and then trillions of cells are getting created. Similarly, mitochondria are dying in trillions of trillions, or I don't know, some bigger word for it. Having more means the cell can afford to lose some without energy crisis. This is another reason for packing more mitochondria than just making existing mitochondria do more work. Fewer mitochondria means any damage immediately compromises the total cell function. So this is a very interesting aspect, right? It's like building good amount of redundancy. If you have only, let's say, few mitochondria and they fail, then your entire cell function fails. But having more, but each of them operating at a certain, let's say, limited number at 60% or 50% gives you good amount of redundancy, and the cell function doesn't get compromised at all. Great. Another thing I want you to also know is I was asking what happens if mitochondria keeps increasing? How can the cell keep growing? What really happens there? So apparently this is also very, very interesting and fascinating. Cells don't infinitely expand. Yes, there is a space constraint, but they don't infinitely expand. What actually happens is the cell becomes more efficient at mitochondrial packing. The inner membrane folding, that is called as the cristae, becomes denser, fitting more functional surface area into the same physical space. It's like packing the clothes tightly into the same shelf or a drawer, where instead of just crumpling it, right, it kind of folds it really better so that you can pack more into the suitcase or your drawer, right? That's a way to imagine it. Always good to visualize. Other organelles within the cell, just like mitochondria, they don't get displaced. The cell dynamically reorganizes its internal architecture. In muscle cells specifically, chronic training causes the actual muscle fiber to grow, hypertrophy, creating genuinely more physical space for additional mitochondria. So this seems to be some kind of a exception to the norm. We'll speak a little bit about mitophagy. Beyond a certain point, the body actually prioritizes mitochondrial quality over quantity, which is exactly what mitophagy achieves. It removes low efficiency mitochondria, so the power plants that are not producing the guaranteed output, and the remaining ones are higher performing. So the system self-regulates fission, fusion, reuse parts of the working mitochondria, etc. An elite endurance athlete cells are actually show this, it seems. Their mitochondria are not just more numerous, they have dramatically more complex inner membrane folding, higher enzyme concentrations, and more efficient electron transport chains than untrained individuals. So athletes function really well for a reason. The questions in terms of what does the cell decide to do? Does it, like, when does it do mitophagy versus autophagy versus repair versus building new? The cell has a layered decision hierarchy, so I'll just read that part. Repair the damage if possible. Heat shock proteins, cold shock proteins, DNA repair enzymes, etc. That's the path it takes for logic number one. If that logic fails, or let's say the repair takes too much effort, or the damage is too much that it can't be fixed. The car is like really bad. Remove the specific damaged component, that is your mitophagy, autophagy, etc. If damage is too extensive, kill the whole cell completely, that is your apoptosis, right? Okay, another new term. If after all of this, clear the debris efficiently without disturbing the neighbors, right? So apparently one cell can damage another cell, etc. So you have to be very careful. So that's why clear the debris efficiently without disturbing its neighbors. Given a good deep dive into mitochondrial health, what you should avoid, what you should do, and what are the types of food and exercise that will help you have better mitochondrial health overall. So hope this really helped understand a lot of how your internal cell functions, how mitochondria functions, and why it is very important for you from a health, longevity, and let's say beauty perspective as well, if somebody is into that. Health is not just the absence of a disease, is the presence of energy. Let's get more energy from your mitochondria. Do things that will promote the same. If you found this session pretty useful, send it to your friend who has low energy, or if someone has high energy, talk to him and ask him what he does, so that he has a lot of high energy.